Hey everybody, shop time with Dave. Well, it's time to start a new project. Now, this has been a project on my mind for probably 5 to 7 years, and I never really knew if I would start it or not, and hey, who knows if I'll even ever finish it. But we're going to start a locomotive. So, let me get you flipped around here, and I'll show you some of the background work that I've been doing to get us started on this project. This is the inspiration for our project. Now, for quite some time, I've wanted to model the classic American 440 configuration. And when I got this book, I decided this is the one. This locomotive was a locomotive that was used in the town where I am from sometime, I would say, in the 1850s, 1860s time frame. I wish I had a better picture, but this is what I got to go off for the time being. But this one was known as Old Bessie. And when I saw this picture, I knew this is the locomotive I needed to model. Doing my research, I came across a whole cache of drawings, such as the ones that are on the screen now. And these became my basis for my modeling. As you can see, there's quite a bit of dimensions to go off here. And this really helped me out for creating the dimensions for the models that we're going to go on and see next. Here's our first model. Obviously, you can see some of the similarities to the drawing. I took those drawings, modified them for my needs, and created each component that you see here on the screen, like, say, these wheels, or these tie bars down here, the transom and the bolster. Got our little axles in there. We can flip it around and look at different angles. It's really nice to be able to do this, see how things are going to fit together and line up long before you ever cut the very first piece of metal. Once our model is completed, I move on to creating the drawings. Here's our first example of a drawing. And I'm going to go ahead and just put this out there and say these aren't as good as real engineering drawings. These are more like, for me, personal notes to keep track of where I'm going and all the dimensions I need. Well, let's look at what we got here. A little bit of information, what material I prefer to use. I may substitute something else along the way, depending on what I'm able to source. You can see there's a bunch of different dimensions in here. Our overall length, some different widths. So this is our main frame that everything's going to attach to. Our next drawing here is the bottom, basically, of the frame that'll get bolted through. What we're going to see in the next drawing will be the little pedestals. But these tie the pedestals together, and the pedestals tie to the frame. And here's our little pedestals. As you can see in the notes down here, we need to make 8 of them. Should be an interesting little piece to make. Got some holes to drill and tap. Next up, I'm calling this the axle block. These will ride inside of those pedestals and carry the axles. And you see down here I have a bearing specified to press into this bore right here. Now the originals on the real locomotive, those just rode in brass with oil and grease. But I thought it'd be pretty cool in our limited space to go ahead and just use some sealed ball bearings. I think it's going to work fine for this application. Next up, here's a little drawing of our axle. Going to be 8 inches, 297 thousandths wide. We're making it out of 1045 cold rolled steel. We're going to start with a 5/8 round stock. We'll have to add some centers to each side, then turn down the ends of the axles to fit in the bearings and the wheels. Next drawing here is the transom, and this bolts to the top of the frame and acts as the joint between the frame and the bolster and creates a pivoting motion or sway motion to allow the front of the locomotive to follow the rails. Then our last drawing we're going to preview here is the bolster. The bolster is going to attach to the transom and to the bottom of the cylinder assembly and create the swivel so that the pilot truck can follow the rails. So that's where we're at with drawings. I do have a few more drawings ready to go. They're just little filler pieces here and there. That kind of wraps up the pre-work that I've done. But before we move on out to the shop and actually start doing something, I want to go ahead and bring up a couple points. One is, with a project this big, there's no way that I can put everything out there. I got to be a little more selective on what we video because it just takes too much time. And sometimes I just want to get out in the shop and just work and not have to worry about the camera and listen to music and just do some stuff, have fun. I mean, that's what it's really all about. It's having fun. And the other thing is, I'm going to need a lot of help on this project. The first thing I'm going to need help with is, what do y'all out there want to see? Do you want to see more of this background engineering work, research, the CAD modeling work, creating the drawings? Or do you just want to see cutting, turning metal? So I'm going to need your help on that. Leave it down there in the comments, and let's see if I can get out there and get some stuff done. I'll definitely record the most interesting or little tips or tricks along the way, but let's get out there and get something done. Let's get started. So we're out at the mill now, and as you can see, I got some numbers written in here and scratched out. As I went along, I started finding mistakes, to be expected. But I thought I'd start with our main frame. Let me pan over here. Here's where we're at so far. Like I said in the intro there, there's just too much going on this to be able to film everything. So I went ahead and just got started. I started with our two main frame rails, and I kind of tack welded them together so I could drill all the holes at the same time, and they'd come out exactly lined up perfect. And then I got to thinking, how am I going to keep these all square? This thing needs to be perfectly square. So I cut some more, and I set holes at exact points to where all this would come together. And then using the vise, I can keep everything perfectly square and aligned. I thought that was a pretty good trick to use, using these roll pins. They spring out and hold tight in there. If I'd have used just screws in there, it'd been sloppy and it wouldn't have held it perfect. I'll go ahead and throw some tack welds on this, make it a little more permanent. Okay, I got it out of the fixture. Got some tack welds on the corners. Now we can flip it over and weld it in. I did bevel these out pretty good here, about a 45. Gives a lot of room for some weld in there. Hopefully we don't warp it up too bad. Let's go ahead and weld this real quick. Alright, I got the metal hot glue gun out. Let's see if we can zip these together. I don't know if it was necessary or not, but I went ahead and bounced around from corner to corner to kind of keep some of the heat down on this. So I can go ahead and grind those down. And the top side of our mainframe pretty much done. Pop this X piece out of here. In a stroke of genius, I just used what's going to become the bottom part of the frame, what they call the tie bars. And some of these hole locations are already put in the right place. Now I need to go back and put the rest of the hole pattern into it. I'll do that off camera. It's just drilling holes. And the tie bars will be done. Here's our frame. And our two lower tie bars sitting on top of their mating drawings. Now we got to make some more parts. See if I can get you zoomed in. We're working on the pedestals now. It's more work for the framework. So here's our drawing. And y'all be appreciative that I didn't take you along for the excruciating hours and hours of milling all these blanks. Each one of these blanks in every dimension is probably within 1 or 2 thousandths of an inch of each other. And like I said, I spent hours working on this to get them all the same. The next thing we need to do is start drilling and tapping a hole pattern into them. If we look at the drawing over here, 3 on the top, 2 on the bottom. I think it'll be best to get those drilled and tapped next. Let's do some center drilling. Got a piece in here and I got a good hard stop set up for repeatability. This back jaw is good and solid so we can repeat off of it. Now, to do that a whole bunch more times. With all those holes spotted, time to start drilling. I want to try to keep this clean so the chips don't throw me off one way or another. Now a bunch more of them. Now that we got some holes in there, time to tap. Just put some happy juice on there. A little down there in the freshly drilled hole. And we're just going to take it easy and hand tap it. I like these spiral flute taps. You see how it pulls the chips up and out of the hole? That's nice on these blind holes. The chips don't pack up down in the bottom where you can't get them out and risk breaking the end of the tap off. Some pretty good sharp tap here. Look at these chips up here, how they come out top. That is nice. I think we're at the bottom. A little easier coming back out. And there's a tapped hole for us. From this shot, you can clearly see why I always make copies of the drawings or manuals or whatever I'm going to be using, because you can see stuff out here gets pretty dirty pretty quick. But if we move in a little bit closer, the next thing we're going to do is knock this corner off and bring our dimension into 688. Here's the setup. We're up against this stop again. Got an end mill in here. It's held real nice. Let's see if we can knock that corner off. Back at the drawing, I think our next step is going to be right here, this little radius. I'm sure there's better ways to do this than what I'm going to do it, but this is the repeatable way to get that radius in the same place each time. And as we see here, 1/8 inch radius, which equates to a 1/4 inch diameter. So we'll finish out with a 1/4 inch end mill. Like so many other times, we'll start out with spot drilling or center drilling. Now we're going to go in and open this up with a 7/32, or roughly 219. Our last step, I'm going to take a 1/4 inch end mill, just plunge right through, and that'll give us our radius. Now let's pop another starter hole in there. This will be for the larger radius. Now let's take a 1/2 inch drill and open it up a little bit. Grabbing as it's trying to pop through the other side. Had to order in a special 15/16 end mill and a special collet just to hold that. Now we can widen the hole out to its final diameter. Let's see how this does. Easy does it. Doesn't hurt to add a little extra lube in every once in a while. Snagged, didn't it? And we're through. One more step done. Next step, now we have this opened up, we're going to drop the end mill down in and come across and make that straight or flat, depending on how you're looking at it. I'm bringing it back in to where we started, so it'll be ready for the next piece, because there is 8 of these to do. We're to start out, we're going to plunge through where we already have our 1/4 inch hole. We're going to move towards the front, come back till I hear a little bit of a squeal and know that I'm in the back again. And then we're going to come straight towards you and knock out this block here. All goes well, we'll have a pedestal. Slow and easy wins the race. It'd be terrible if we pushed it too hard and broke that end mill off. Starting to break through the wall. All right. Come back till we hear a little squeal, and we'll know we're in the corner where we need to be. All right, we're there. Moving towards you now. We'll start to see this block break away. Okay, the block broke away. Go just a little bit more, clean it all the way up to the corner. All right, And then we'll back in until we hear the squeal and we'll be back at the beginning again. And there we have it. There's one pedestal. A bunch more to go. Last screw of this assembly. Y'all see that? Starting to make a little bit of sense. Well, here we go. That is the frame for the front pilot truck. Well, I think we're going to cut the video here. It's gotten pretty long so far. A lot of things got covered, but this is just the introduction to a really big, long project. As you can tell, it takes a lot of time to make each one of these little pieces, and there's just no way, like I said before earlier in the video, there's just no way that I can film everything and show every little detail of this project. It's just way too big. But if you've hung around this long in the video, let me know down in the comments what kind of material that you'd like to see in this video series, whether it be more machine work or more computer work or more research or what you're interested in. But leave that down in the comments for me, and thanks for watching, and come back for more Shop Time with Dave.